In this video, we're going to be going over the proof of the cosine's derivative. The cosine function, the cosine of x's derivative, is equal to the sine function. And as a review, the derivative for any function of x is defined by the limit as h goes to 0, h representing the change in x, as h goes to 0 of the f of x plus h minus f of x divided by h. So with this limit, we can begin to prove our derivative for cosine of x. We can simply apply f of x to be cosine of x to get the cosine's derivative is equal when the limit of the change in x represented by h goes to 0 of the cosine of x plus h minus cosine of x divided by h. This is then equal to the limit as h goes to 0 if we expand out the cosine of x plus h to be equal to the cosine of x times the cosine of h minus the sine of x times the sine of h minus the cosine of x. This then divided by h will be the same thing as our original limits definition, because all I did here was apply the trigonometric property of the cosine function of any two numbers added together, represented by alpha and theta, is equal to the cosine of theta times the cosine of alpha minus the sine of theta times the sine of alpha. So I applied this into our limit to obtain what I just got right here. This can then be further expanded out to be equal to the limit as h goes to 0 of, if we factor out the cosine of x from these two terms right here. So the cosine of x times the cosine of h minus the cosine of x both contain a cosine term. So we can factor the cosine x out of these two terms to get the cosine of x times parentheses cosine of h minus 1 minus sine of x times the sine of h divided by h is equal to the derivative of cosine of x, because all I did here was factor out the cosine of x from the two circled limit terms in green. So with this, we can, if we scroll down and give ourselves some space, can be then further simplified into the limit as h goes to 0 of the subtraction of two limits, which is the limit as h goes to 0 of cosine x times the cosine of h minus 1 divided by h minus the limit as h goes to 0 of the sine of x times the sine of h divided by h. And we can do this because, as a review of the limit property of two functions subtracting with one another, which is the limit as the input of x approaches to some number of n of f of x minus g of x is equal to the limit as x approaches to n of f of x minus the limit as x goes to n of g of x. This is a limit property which we just used to obtain this limit quantity right here. We broke up the limit to be the subtraction of two limits. Then from here, we can analyze our first limit portion, which I'm going to circle in this green color. So if we're going to analyze this green limit, the limit as x, or h rather, goes to 0 of the cosine of x times the cosine of h minus 1 divided by h. This term right here is equal to the product of two limits, which is then equal to the limit when h goes to 0 of the cosine of x times the limit h goes to 0 of cosine of h minus 1 divided by h. The reason why we can do this again is because of another limit property, which states that the limit as our input variable of x goes to n of the product of two functions represented by f of x and g of x is equal to the product of the limit as x approaches n of our first function f of x times the limit of our second function g of x when x approaches to n. Therefore, we can apply it to obtain this limit right here. And we know from our limit properties that the limit when x goes to 0 of the cosine of x minus 1 over x is equal to 0. Therefore, we can apply this limit property right here into this limit, which I'm going to circle in this light blue color. This limit in this blue color circled is nothing more but 0. So 0 times the limit as h goes to 0 of sine of x, well, 0 times anything will be equal to 0. So this green limit turns out to be nothing more but 0. So if we scroll up, we can see here that the green circled limit right here, this whole thing is nothing more but the 0 term. So all we have left now is when 0 minus the limit as h goes to 0 of sine of x times sine of h divided by h. And now we just have to evaluate our last limit right here, which I'm going to circle, yellow color, and then we're done with the proof. So to analyze this limit, the limit as h goes to 0 of sine of x times the sine of h divided by h is equal to the product of two limits, which are the limit when h goes to 0 of sine of x times the limit when h goes to 0 of sine of h over h. And all we did here was apply the previous limit property, which I've stated before, the limit as x approaches to some number of the product of two functions. And let us evaluate this limit right here. That limit is nothing more but sine of x times the limit as h goes to 0 of 1. And the reason why I can say this is because the relative to which variable we're taking the limit of is the variable of h. The x variable in sine of x has nothing to do with the h variable right here. So we can treat sine of x as a constant. And we know from a limit property, once again, that the limit as x goes to any number of n of a constant represented by c times our function of f of x is equal to, if we take the constant out of the limit, times the limit as x goes to n of our f of x function. Therefore, since sine of x in this case is our limit's constant, this will then be equal to the sine of x function times the limit as h goes to 0 of 1 times the limit as h goes to 0 of sine of h over h. You may recognize this limit right here to be part of another limit property, which that limit property, if I draw it out in red, states that, if I scroll down, that the limit as x goes to 0 of sine of x over x is equal to 1. So this limit right here is nothing more but 1. So this whole limit, so the limit as h goes to 0 of sine of x times sine of h divided by h, will then be equal to nothing more but the sine of x times the limit as h goes to 0 of 1. And we know from another limit property that the limit as x approaches any number of a constant is equal to that constant. And since 1 is a constant, no matter what variable is approaching to 0, this will always be 1. So this will then be equal to sine of x. So our second limit product results to sine of x. And if we scroll up, we can evaluate this equation right here. This will be nothing more but 0 minus the sine of x, which will be equal to negative sine of x. So for a conclusion, we just proved that the derivative of the cosine function is equal to negative sine of x. And along with the previous video where I proved the derivative of sine of x, these two derivatives, which are the sine of x derivative and the cosine of x derivative, which are equal to cosine of x and negative sine of x respectively, are two of the most essential and important derivatives necessary to understand calculus. So make sure to understand these two trigonometric derivatives very well. And in future videos, we're going to be proving the other four trigonometric function derivatives. But for now, this will be the proof of the cosine of x's derivative.